Hey there, this is CUSD Math 7, Unit 5, Lesson 9, Multiplying Rational Numbers. Okay, so your first activity is kind of a cool down from today, just some basic multiplication equations here, and you have to decide if the equation is true or false. I just want you to check one or the other, true or false. But the key thing today was you probably talked about that if you take a positive number and you multiply it by a positive number, you end up with a positive result. A negative number multiplied by a negative number gives you a positive result. So in multiplication, when we have the same signs, we end up with positive. If I do a positive times a negative or a negative times a positive with different signs there, then I end up with a negative result both times there. Okay, that's kind of your key thing from today, so keep that in mind as you're looking at these equations here. Right, a positive times a positive gives you a positive answer. And yes, it is 56, so we would say that is true. So do the rest of those and you'll be good to go. All right, let's look at number 2. Skydiver was descending, going down, at a constant rate of 16 feet per second. So that's a rate of negative 16 feet per second. All right, if he continues to descend, going down at this rate, how far will he have fallen in 20 seconds and in 60 seconds? Okay, so how does this work out? We have to take our number of seconds and we're going to multiply it by our rate. Okay, so we can take, I'm going to do the first one here for you. We do 20 seconds and we're going to multiply that by a rate of negative 16 feet per every 1 second. Okay, so I wrote it like this so you can see that what happens is this is 20 seconds just by itself and negative 16 feet for 1 second. That's a rate. When I multiply seconds, think of this as a fraction bar here, I can reduce the seconds. The second cancels out the second, so the seconds go away. So now I'm left with really 20 times negative 16 feet. And 20 times negative 16 feet is equal to negative 320 feet. So what's happening for the skydiver as he's descending, as he's going down? In 20 seconds he will have gone down negative 320 feet. That's how far he would have fallen. So how far would he have fallen? He would have descended negative 320 feet. So again, this is one of those magnitude questions. If it wants to know how far that is, as a distance, it's still just 320 feet. That's the distance he's fallen, technically. If you're measuring it as a comparison on the elevation thing, we would say it was a negative 320 from where he started, but we know that the distance is still 320. So the key thing here is 320 more than anything else, because that is what's happening to the guy. Now do the same thing for 60, but instead of doing 20 seconds, you do 60 seconds there and see what you get. All right, number 3. Do a couple of these here. Let me look at B and E. We have a 30 times 20, which is 600. Yay. But a negative times a negative is a positive, and that's it. E is a great one because we have a fraction. Fractions are lots of fun. So we're going to multiply straight across. 5 times 7 is 35. Keep the fraction bar. 2 times 2 is 4. A negative times a positive is a negative. And we're done. So I just want to show that one because sometimes kids think, oh, I'm going to add them up now. This is multiply. So always look at what it's asking you to do. Okay? And that is really it for that one. Okay, number 4, more money problems. Kieran had 4 withdrawals, right? So withdrawal is always negative, we said. And she had 4 withdrawals of $40 this month. Write an expression that represents this situation. So we had this on yesterday's math problem. It was like 8 times something or other. So we said, okay, for 4 different times, she had a withdrawal. We'll say it's negative, and she withdrew $40 4 times. So that's how we would write an expression there. Okay? Then it says how much money was withdrawn for this month. That means they want you to do what? They want you to solve it. So now take a look at that and go ahead and solve it and get an answer for them. It's going to be some amount of money. All right, number 5. What is the value? Good fraction problem here. We have subtract, add, In order to do that, we have to have a common denominator. Okay, so for when I look at this here, I know 2 and 4, those go well together, but that 5 is a little bit off, right? So I got to think about multiples of 5 when I want to find a common denominator. My options for 5 are I have 5, which doesn't go with 2 and 4. After 5 comes 10. 10 goes with 2, but not with 4. 4 is 4, 8, 12, not going to work. My next thing is 15, which doesn't go with either. And my next 5 in multiple is 20. 20 is even, which means it's for sure going to go with a 2. And 4 times 5 is 20, so 20 is going to be my common denominator. So I want to rewrite this here. I'll write a 20 minus a negative 20 plus something over 20. So all I've done is I've said I want my common denominator to be 20 for this one, and this one. And I wrote out the problem again with the denominator all being the same, and my my work being the same here. So I'm going to subtract a negative and add over here. So now let's get the top number right. I got a 1, a 3, and a 3. Need to fix those. So 5 times what number gets you to 20? Well, it's 5 times 4. So what is 1 times 4? 1 times 4 is 4. So that becomes our numerator there. 2 times what number gets you to 20? Well, that's 10. Let's do the same to the top. 3 times 10 is 30. So we'll put 30 right here. And then 4 times 5 gets you to 20. So we'll do 3 times 5 to get 15, and we'll put that number right there. All right, that's awesome. So now what we have is we have all this has a 20 as the denominator, so we can rewrite it like this. And a way to think about this is now I have 4 minus a negative 30 plus 15. That's really what I'm doing. It's just that simple part right there is all I'm going to do. Now the denominator is the same. So when I subtract a 30, that's like adding. This becomes adding. So 4 plus 30 is 34. And 34 plus 15 is equal to 49. And the denominator stays the same, 20. So we have 49 over 20, and that's what we have there. All right, number 6 real quick. We can multiply this out, but take a look here at the order that you want to do things in, okay? It's really important to take a look at what they give you. Yes, you could multiply 8 times 15. I would not want to start there. You want to find a way to make this fraction nicer to work with. Notice that the fraction has a denominator of 3. They pick 3 because 3 goes into 15. If I reduce here, now I have nice numbers to multiply. Let's do the reducing part, and I'll let you finish the rest. So the 3 goes into 15 5 times. So now what I have, if I rewrite this, is negative 8 times 5. And what do I have left in the fraction? 2. That's probably a little bit easier to look at and see what you come up with. So you go ahead and solve that part right there. And our last one, Andre is running around laps around the school track during practice. What's the perimeter? The perimeter is the distance around something of this track. Well, let's take a look. Well, the perimeter is going to be this section right here plus this half circle plus this section plus this half circle. They tell us that this length right here is 277, which means this length right here is also 277. So that part, the straightaway part, is pretty easy, right? 277 plus 277, 14 carry the 1, 15 carry the 1, 554. But I need to do 554 plus the distance around the 2 half circles, and 2 half circles altogether make a whole circle. All right, and what do we call this distance around a circle? We call that the circumference, right? So to find the circumference of a circle, we figure that out by doing the diameter times pi. Do we know the diameter of this circle? That's the distance across from one edge to the other? Sure, right here. Here's our diameter. Our distance apart is this length right here, which is 135. So 135 pi. Okay? So I'm not sure if your teacher wants you to multiply this together and use your calculator to figure that out, or if they want you to leave it in pi. But basically, your problem is pretty much solved here. You're going to have a distance of 554 plus 135 pi. That becomes the total perimeter. Again, they might want you to plug it in. I'm not sure. It'd be a good question to ask. And on your own, you can use a calculator and do this part here, 135 times pi, and then combine those together to get your total. That's fine. Sometimes you might just leave it in that form. You could just say 554 plus 135 pi and leave it like that. So ask and find out and see what they want you to do. All right, that's it for today. Have a great day, and we'll see you next time.